Today we are going to talk about seasons, and you're actually about to do a virtual lab, but before you get to that, I wanted to make sure there are some vocabulary words that we all remembered. So these should all be reviewed, but if you have the Earth, you have the equator going straight across. That's 0 degrees latitude. Hopefully, you do remember that from Unit 1. If you're still mixing up latitude and longitude, make sure you go back and study that. So that breaks up the Earth into the northern hemisphere, where the North Pole is, so there's my little snowman. And then you've got the southern hemisphere, and there's another little snowman. So we got the North Pole and the South Pole, and the northern hemisphere and the southern hemisphere. Now, going through both poles is the Earth's axis. So going straight through. Now, if you remember me talking about the Earth's axis, this isn't a line like longitude going around the Earth. This is like if you drove a stake straight through the middle of the North Pole and straight out the bottom of the South Pole. So go through the core of the Earth, which would not be good for our poor little snowman here, but that's how you can imagine the axis. Remember, rotation is just the Earth spinning in place, and orbit is the Earth actually, if this is the sun, orbit is the Earth going around a fixed path. So that is the orbit. And remember, all orbits are an ellipse, and we know that because of Kepler's first law, which means that it's an oval shape. So with those vocabulary words in mind, we are going to be able to go ahead and start our lab. So the way this is going to work is you're going to go to Canvas, and in Canvas there is a season simulation lab. You aren't going to do the lab on the computer, or you're going to do the lab on the computer, but you're going to write out the lab on the handout that will be passed out. But on Canvas, there's a link, so the season simulation link. If you click it, this is what it should take you to. And I just want to show you how to use this real quick. This is the Earth. You can move the Earth around, so if you're impatient and you want to move it, you can. The X that's about to show you in a second, that's where we are located. So that's your position, and that is in the northern hemisphere. So it's going to show you down here daytime versus nighttime. And over here is going to be your temperatures, and over here is the angle of the sunlight. Part of your lab is going to ask you when the sun rises and when the sun sets. So when the sun rises, let's see, we'll stop the timer right about here. Now, if you and your partner are disagreeing on if it's 7 a.m. or 6:30 a.m., that's not a big deal as long as you're close. But you can stop the timer as soon as you start to see daylight, and that is the sun rising. You can slowly play it and then stop again as soon as it starts to get dark around 4 p.m., and that would be the sun setting. Okay, so you're going to need to be able to do that. So if you need to watch for the sunrise and sunset using the slow the slow button is going to be the easiest way to do that. Now, if you're wanting to watch how the angle and the temperature changes as the Earth goes around the orbit, then if you click the fast button, then you can watch it go much faster, and you can watch as the angle or anything changes. Now, right now, the angle and temperature is not changing. This is what we call our inclination angle. So in your lab, it's going to tell you what to set the angle to. Right now, it's at 0 degrees. You'll change the angle to whatever it asks you, and you'll notice that as you do that, you're going to start to see some changes. So if I play fast again and watch it, you can watch these angles change, and you can watch this temperature go up and down. So the lab is going to be very straightforward, specific questions, just getting you to change the angle and then just write down your observations. One thing I did want to point out is the lab will ask you, when is the angle of sunlight the most direct? If something is direct, that means it's straight up and down. So if this is the Earth, it's just pointing straight at the Earth. Now, if your angle is slightly off, but if it never goes straight, it just goes a little bit angled, that's still very direct. So where within the orbit, where within the path along the sun is it going to be the most direct is what you're looking for. So just again, here's the fast button, slow button, stop button, and then your angle. So make sure you're paying attention to all that. Again, the instructions are pretty straightforward, so you should be good. So I'll go ahead and let you pause this video while y'all work on the lab.